Okay, so hey to you all guys. Right now I have just made a very beautiful little short notes for solubility with all the formulas written in this. Now let's do one thing, revise the formulas and then we'll go for some questions. What is solubility? Solubility is basically uh, a chapter in your class 12th. Okay, fine, jokes apart. Solubility is the property of some material or some element to get mixed into another. What all things are going to study in this chapter? Firstly, let's talk about moles. How can we calculate moles? That is N. It can be calculated by the given mass by the molar mass, that is W by M, or it will be calculated by the number of moles, that's right, number by the Avogadro number, or it can be calculated by the volume given by 222.4 liter. So that's about the moles. Now let's talk about a few important formulas, that is W by V is equal to percentage W by V is equal to W, that's the weight of the solute by the volume of solution in milliliter into 100. V by V basically shows the volume of solute by the volume of solution in millimeter into 100. Molarity basically shows the N solute by volume of solution in liter. Molarity, okay, remember this, that you have molarity and there's another which has molality. Liti shows the word liter, but of course you don't have liter completely written, so the formula also doesn't have liter. The other one, that is molarity, has the liter, that's volume solution liter. Okay, now molarity can also be written as W percentage W by V into 10 by molar mass of solute. The weight of the solution is equal to weight of solute plus solvent. The volume of solution is equal to volume of solute plus solvent. Normality is the equivalent solute by volume of solution in liters. How can we get the equivalent solute? That is weight by equivalent mass. Now how can you get the equivalent mass? That is, I guess, molar mass by the N factor. And what is the N factor? That is the number of H plus ions that some compound releases. Okay, percentage W by W is basically W of solute by W of solution into 100. Mole fraction is the moles of a substance by the total moles. Mole fraction of solute plus mole fraction of solvent is equal to 1. Molality is basically N solute by weight of solute in kg. I guess something is wrong here. It should be the weight of solvent in kg. Yes, please make the changes. I'm so sorry. Okay, so now let's talk about molar mass theoretical by molar mass absorbed. That is 1 plus n minus 1 alpha is equal to I. I is basically Wolff's constant. Now n is the number of ions and lambda is basically the degree of dissociation or ionization. We're talking about strong electrode. We have alpha 100%, that is alpha 1. N is also 1. The theoretical is more than the molar mass absorbed. Now we have some examples, that is strong acid, HCl, H2SO4, HNO3. They are strong electrolytes, so their alpha is 1. The strong base, that NaOH, KOH, BaCO, COH whole twice, is a strong base because the alpha is 1. When you talk about the salts, you have NaCl, KCl, K4, FeCN6, which is also salt, which is therefore strong electrode. Talk about weak electrodes, they are less than 100%. The I is not equal to N. The weak acid is CH3COOH, HCN. The weak base is NH4OH, R, NH2, and you have the benzene at the para position. You have uh, I'm so sorry, it's the ortho position, right? At the ortho position, you have the NH2. Okay, now this was for ionization or dissociation. What about association? For association, you have different formulas, that is uh, molar mass theoretical by molar mass absorbed is equal to 1 plus 1 by n minus 1 beta is equal to I. Okay, there the formula was 1 plus n minus 1 alpha. Now here n की जगह 1 by n. Okay, and this is the degree of dissociation, that's beta. Non-electrolyte alpha is equal to I is equal to 1, molar mass theoretical is equal to molar mass observed. It's shown in urea, glucose and sucrose. Now what's the difference between the two? Association is when you associate something, when you join something. Dissociation is with mostly when you dissociate something, break something. N observed is equal to I into N theoretical. N observed is basically weight by molar mass observed, and N theoretical is basically weight by molar mass theoretical. Osmotic pressure is pi. Pi is directly proportional to temperature, is directly proportional to the concentration, is directly proportional to the M, and directly proportional to I. Okay. Pi is equal to nth, that is moles theoretical, into I into RT pi volume in liters. When two or more solutes are mixed, when two or more solutes are mixed, then the pi total is pi A plus pi B plus pi C, and that's NaIA plus NaIC plus NCIT and all those things. Then basically you have when two or more solutions are mixed, non-reacting solution, and pi total is NaIA by N plus NBIB plus NCIC by V1 V2 by V3 RT. Reacting solution is basically when you have a LR, you cancel it and the rest all are added. When two solutions mixed form PPT, PPT is not considered in pi, that is osmotic pressure calculation. So you have MAIA RT is equal to MBIB RT. Boiling point temperature, when the temperature increases, vapor increases. If the delta VB increases, I increases, delta P of solution increases. Delta TB is basically the elevation in boiling point. Now let's talk about delta TB, that's directly proportional to M. The constant Kb came in between, that's molar elevation constant. Delta TB is equal to delta B into W solute into I into 1000 by molar mass of solute into weight solvent kg. If solvent is H2O, TbH2 is 100%. If solution is unknown, not needed to consider. Depression in freezing point. Basically, H is equal to negative, then H is directly proportional to Y by R. Delta TF is equal to TF solute minus TF solution. Delta TF is M. Okay. Now we come to Raoult's law. That's basically the partial pressure is directly proportional to the moles fraction. For NVS, that's a homework. Please look for MVS full form and the location, and then for what function and all. PT is equal to PV into XV. Now PV is the solvent partial pressure and XV is basically the solvent mole fraction. PS is equal to P naught into X solvent. Solute is N volatile PA. Dalton's law of partial pressure. PT is equal to PS is equal to PV into X solvent. Okay. Okay, after this we basically have the ideal and non-ideal solution and nothing much, just this much explanation is needed, and then we move to the questions which will be in the different audio because now this makes me feel a bit lengthy. We will continue on electrostatics as well as on solutions. Thank you.